Welcome to the Solocast of Firecode Tech. In these episodes, it's just going to be me, your host, Gus Gagliardi. There's going to be a range of topics, but I'm going to talk about specific technologies, installation standards, codes and how they work, as well as some other interesting topics that don't neatly fit inside of the context of a normal interview. Hello all, welcome to episode 35 of Firecode Tech, the Solocast series. On this episode, we're talking about antifreeze systems. Yes, recently I had done some research for a study in a job that we were working on, and I was able to look at some preliminary details about antifreeze systems and some different listings and manufacturer qualities of the couple of listed antifreezes there are out there, and learned a bit about how these technologies work and the salient factors around implementing these systems. So, wanted to relay what I had found in my research. I'm by no means an expert in antifreeze systems, probably only have interacted with one or two during my career, but I think they have a unique application and a set of problems that they can solve. And so I wanted to speak about those pros and cons in this Solocast. This is your first time to listen to a Firecode Tech Solocast or a Firecode Tech in general. Welcome, and don't forget, if you enjoy, to please subscribe so you don't miss any episodes on content or topics that you would be interested in. Also, if you want to give us a 5-star review on Apple Podcasts, that would be a big help, and I would greatly appreciate it. Let's get into the show. Let's start off with the basics. Antifreeze sprinklers or antifreeze sprinkler systems are a subsect of wet pipe sprinkler systems, and it utilizes a additive to the sprinkler system in order to provide a listed fire suppression system that is capable of operating in environments that are below 40 degrees Fahrenheit. Speak about the codes and standards portion of this system. When you find out that you have a need for a fire suppression system or a fire sprinkler system, to be more specific, you would determine that with the International Building Code, assuming that you are working in the U.S. in a jurisdiction that adopts these codes. And then after you have determined that the sprinkler system is required, you would go about designing the sprinkler system for the facility, and maybe you have a attic space or a unheated space in your facility that requires a system with freeze protection. So that limits your options to dry pipe systems, pre-action systems, antifreeze systems. You could try to use dry barrel sprinklers. In fact, I'm realizing as I'm saying all these options, I definitely need to do a Solocast episode over just freeze protection. But suffice it to say, after you determine that you need a sprinkler system and that the space is not going to be heated on a regular basis, or there will be times in which the space will be below 40 degrees Fahrenheit, then you can elect to use a antifreeze sprinkler system. And so if we look in Nfpa 13, in the definition sections, it defines antifreeze sprinkler systems. And it says 3.3.206.1 antifreeze sprinkler system. And this section says a wet pipe system using automatic sprinklers that contains liquid solution to prevent freezing of the system, intended to discharge the solution upon sprinkler operation, followed immediately by water from a supply. Let's cover another definition since we're in Chapter 3 and just talk about the antifreeze solution, or as it's defined in Chapter 3 of NFPA 13. Specifically, I'm looking in the 2019 edition. It's 3.3.10 or 0.160, and it's called Premixed Antifreeze Solution. And this definition says a mixture of antifreeze material with water that is prepared and factory mixed by the manufacturer with quality control procedures in place that ensures the antifreeze solution remains homogeneous and that the concentration is as specified. So this gets at the point of why antifreeze solutions were antifreeze systems were not in use for a number of years. There were some significant fire events due to the improper mixing of antifreeze solution. Antifreeze is a mix of, generally a proprietary mix of propylene glycol and other additives, and in the wrong concentrations, these solutions can be flammable. So there were some significant fire incidents that happened where the sprinkler system, which is intended to extinguish or control or provide life safety feature for a building, actually added to the fire. And so this was largely, I believe, from my recollection in the brief blog articles I've read over the subject, due to the hand-mixed antifreeze solution. So whoever was charged with filling the antifreeze system, they would hand mix this solution with water in order to achieve the right concentrations. Well, you could see how this would be problematic. But so now they have, in the last 5 years, a couple companies have developed listed antifreeze solutions. So they're premixed, off the shelf, in the right concentrations, and now these systems are being newly installed again. So that's a little bit about the history and some key definitions around antifreeze systems. Yeah, I really just wanted to cover that as a note about these systems and what they kind of are, how you would get to be requiring these systems. But I want to talk further in design limitations and system component architecture, since that is something that I found intriguing in my brief research of the subject. So these systems are restricted in the hazard category that they can provide fire suppression for. So you need to think about the hazard determination of your space before you even elect to design and or specify an antifreeze system. So antifreezes that are listed and available currently are listed for 13D occupancies, 13R occupancies, light hazard occupancies, ordinary hazard occupancies, storage hazards, and they are not listed for ESFR sprinklers. Within these allowed hazard determinations, there are limitations for light hazard, ordinary hazard, and storage systems in regards to volume. So I'm just going to boil right down to where I see the big value add in antifreeze systems. And it is where you can, within the listing of the antifreeze solution, apply the antifreeze system in a way that you can utilize light hazard sprinkler discharge density without having to implement the 30% increase for dry system design. So for those of you who may not be aware, if you design an antifreeze system under the volume thresholds listed in the antifreeze system technical datasheet, so for example, Nfpa 13 light hazard design less than or equal to 200 gallons in accordance with Nfpa 13 design criteria is what you would calculate that system. So this is a big advantage for dry systems over dry systems, because there is a 30% design area increase for dry systems. You have a water supply that is marginal at best, and you are very close to having to be required to have a fire pump or a fire water storage tank. This may be a huge benefit for you to be able to provide a NFPA 13 light hazard design density or a NFPA 13R design density in a freeze protected space. There are some additional equipment differences in regards to antifreeze systems. First, there is the backflow prevention device needs to be a reduced pressure zone fire protection backflow prevention assembly as defined in the International Plumbing Code. Yes, because antifreeze is a high hazard contaminant to a domestic water system, you need an additional avenue of protection than the conventional backflow preventers for systems utilizing this type of industrial fluid. Also, you need a means to fill the system with antifreeze, and that generally looks like a fill cup or a pump in order to hook up to a connection and fill the system with the premix listed antifreeze solution. Also, depending on the layout of your system, you may be required to have a thermal expansion chamber. There are a couple of different physical layouts for these systems, and based on if you have a means to automatically fill and discharge pressure from thermal expansion, you may be required to have one of these thermal expansion chambers. To look up the Nfpa 13 requirements for antifreeze system layout components, you need to look in 7.6 antifreeze systems in the 2016 and earlier edition, or in 8.6 titled antifreeze systems as well for 2019 and on. There are some good diagrams in these photos, and I used to always look at these and not really understand what was going on, but after you take a look at some of the data sheets online for the antifreeze solutions and their listings, and read up a little bit more about how these systems are filled, then these diagrams tend to make a little bit more sense in my experience. There are a ton of different qualities that are important for the specific listed varietal of antifreeze that you are using for these systems. So really dig in deep on the cut sheets for the antifreeze solutions. There are some potential material incompatibilities and specific temperature listings for these antifreeze solutions. I think that's going to do it for this episode on antifreeze systems. I think there's still more for us to talk about on this subject, but we will see you next time. Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.